Okay, this is Friday, May 7th at 10 o'clock. What am I doing? Well, I wanted to go over as I've stated, your final in-class exam is going to be over these videos. I'm just going to select questions from these videos and hopefully you're studying them and it'll be much easier. With my 5 free response videos I gave earlier, 2 of them were proportions on proportions, which would be a Z distribution. No, I'm going to back that up. 2 of them were on inference, and they weren't necessarily Z. Question 2 and question 4. So they will definitely be on the exam, but I wanted 1 more inference question. That's what today's about. So I looked around and I found the 2019, only a couple of years ago, question number 4. And I will post that. I haven't posted it yet, but I'll post it here shortly. And I'm going to go over this one, and this will be the 4th one, which will be a good study target for you. Let me read it. Tumbleweed, commonly found in the western United States, if you watch westerns, you would see tumbleweed, is the dried structure of certain plants that are blown by the wind. Kochia, I believe that's the pronunciation, I'm not sure. Kochia, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from soil that would otherwise go to beneficial plants. Scientists are concerned that Kochia plants are becoming resistant to the most commonly used herbicide, and I believe the pronunciation for this is glyphosate. Glyphosate. That's what I'm going to call it anyway. In 2014, 19.7% of 61 randomly selected Kochia plants were resistant to glyphosate. In 2017, 38.5% of 52 randomly selected Kochia plants were resistant to glyphosate. Do the data provide convincing statistical evidence at the alpha level of 5% that there is an increase in the proportion of all Kochia plants that are resistant to glyphosate? Classic significance test question. So let's go over here and let's get our board out here and let's do it. Let us do it. Let's do it. The first thing I want to do is to come up with a null hypothesis and a alternative hypothesis. Well, first off, we should know that there are 2 proportions here. So this is going to be, is there a difference in proportions? Is there a statistically significant difference in proportion? So the first thing we need to do is write a null hypothesis. And I'm going to do that for you right now. And I'm going to say P to whatever year we are talking about. Remember, with subtraction and a difference, order is essential. So P sub 17 minus P, what was it before, 14, equals 0, meaning there is no difference between the 2, okay? Then the alternative hypothesis is based on how I'm writing this, is that P sub 17 or year 17 minus P sub 14 is greater than 0. Notice I put this one first, the later occurring. If you wrote it the other way, which you could, you would have it the other way around. Okay, so this would be the first part of it. Then the second part would be these assumptions and conditions. Remember, they're no fun, but they're essential to getting top score. So let me read some of them to you. It says the first condition for applying the test is that the data is gathered independently. So both samples were independent of one another. So make sure that you have written that down. The second condition is that the distribution is approximately normal. And that's where you take the combined count, which would be 28.3%, and times it by the samples, and you would find out that both of them are greater than 10. So that works out for you. And then the final one is the 10% condition, making sure the sample isn't too large, and that checks out also. Now comes the most important part, which is coming up with your Z statistic. You might write all conditions and assumptions are met. Therefore, I am going to do a 2 proportion Z test. And now we're going to, if I break down these proportions, they are 0.385 minus 0.197 over, remember, that big standard error formula, which would look like this: 0.285 times. Remember, this is the combined successes. 0.7165 over 61. First sample, plus 0.2835 times 0.7165 over 52. Okay, so you've written this out. Now, to get the statistic, I would suggest you would use your calculator. So get your calculator out and hit stat and go over to tests and down to 2 proportion Z test. And then put in that percentage. The first percentage was 19% of 61. Remember, you cannot have a part of a success. It has to be a whole number. So it ends up being 12 over 61. Then put the other one in, which is 38.5% of 52, which ends up being 20 of 52. So if I put them in like this, which is opposite of how it is there, I would do less than. That was a mistake. I would probably put them in the other way and keep consistent with the way I have it on the board. But it's all up here in knowing how it should be interpreted. Then I would go to calculate, and I end up with a Z statistic of Z equals negative 2.20. And it also gives you the p-value, which is the most important thing. P equals 0.013. 0.013. Okay. Now, in the question, it said use 5% as your alpha level. 5% is less than, 1.3% is less than 5%. Therefore, P is low, reject HO. So I'm going to reject the null hypothesis that there is no difference and say, yeah, there is a difference, and that the alternative hypothesis is the proportion in 2017 is greater, There is a difference, and it is greater. Okay? And my formal statement is, because the p-value is less than 5%, there is convincing statistical evidence to conclude that the proportion of resistant plants in 2017 of the Kochia plant is greater than the proportion of resistant plants of the 2014 population of Kochia plants. And there you go. So make sure you've got the hypothesis, the two hypotheses, mention those assumptions and conditions I talked about, come up with a statistic and a p-value, and then give the interpretation, and all is well. So this question is definitely going to be on our final in-class exam, and also I am hoping it will be a good study guide for the big test. Okay, over and out.